All right, guys. So now we'll move on to the main part of this lesson, right? So we are going to discuss about sketching graphs of hyperbolic functions. Okay, so we'll go through all the graphs and we'll go through them in detail. Okay, so the first one, you can sketch the graph of the hyperbolic function considering the graphs of ex and e minus x. All right, guys. So what are we talking about here? So now you know all these exponential functions, sine, cos, tan, they're all defined in terms of exponential, like ex and e minus x. So those are the two main functions that we use, right? So for, here sine x is ex minus e minus x divided by 2. So that's the main, these are the equations. So guys, what I want to do is before I move on to anything else, let's just remind ourselves of these exponential graphs, basically P3. So if you have y equal e to the power x, do you recall the shape of the graph? So how does this graph look like? So I want you to recall four basic graphs. So e to the power x is actually the exponential graph. It looks like this, right, guys? Do you recall? The cutting point, it cuts the y-axis at 1. And if you recall, this, the x-axis is an asymptote. Right, guys? So this is the basic function of e to the power x. Okay, next I want you to also remember e to the power minus x. So do you recall how this particular graph is drawn? So e to the power minus x is also, it's quite similar except that all the x values are now negative. So the graph is inverted, right? So you get the graph to the other side, a reflection on the y-axis. Right, guys? So you get something like this, e to the power negative x. Cutting point is still 0, 1. Asymptote doesn't change. Asymptote is the x-axis. So you get the same graph, just a reflection on the y-axis. Right, guys? So these are simple things that you should already know. And then the next graph I want you to recall is y equal minus e to the power x. So guys, what's happening here? Now you know how to draw e to the power x, but now it's a negative e to the power x. Basically, you have a minus 1 in front of your exponential function. So what does that minus 1 do? What does it do? What effect does it have? So your EX graph, that the EX values are what gives your, Y values here. So all the Y values are going to be what? Now you can see the EX, the original EX graph, all the Y values are positive. All the Y values are positive. So what this minus does here is it achieves in making all the Y values negative. Right, guys? So this entire graph, you'll have it flipped over to the other side. So it will, that in this case, it's a reflection on the x-axis in this case. Right, guys? Can you see? So you'll get something similar to this, right? The same graph, but flipped over. The same graph flipped over to the other side because your, all your y values are becoming negative simply. The positive 0, 1 now becomes 0, minus 1. All right, guys. So again, these are concepts that you should be already familiar with. Okay. So that's this guy. And then the last one, I want you to also draw y equal minus e to the power minus x. All right, guys. So how does this work? Minus e to the power minus x. So you already know how to draw e to the power negative x. E to the power negative x is this graph, the one I've drawn here, right? So when you give the extra negative sign outside, you know that this negative sign that I'm highlighting is affecting, it's not affecting the x coordinate, it's affecting the y coordinate, right, guys? So here, when you have a minus outside of the function, that's affecting the y coordinate. So the entire graph, e negative x graph is this. This will flip on the x-axis. So all the positive y, you can see e minus x is also a graph where all the y values are positive. So multiply it with this extra negative sign, all the y values are going to turn negative. All right, guys? Okay, so it's the same thing, but you flip it over to the other side. Okay, the same graph 0, minus 1, but it's flipped over. So these are the four graphs. Okay, so these are our four basic graphs, and we are going to actually use combinations of these graphs to define a hyperbolic function. All right, so that's one way of doing it. So let's see how it's done. All right, guys. So let's move on to this. So they say here, in order to sketch the graph of shining. All right, guys. So look at the way we use these four graphs. Okay. So mainly we're going to use two graphs here. So look what we've done here. So shine x is ex minus e to the power minus x divided by 2, right, guys? So you can break it up like this: ex plus the negative e to the power minus x divided by 2. So you can break it up like this, right, guys? It's the same thing written in a different, written in a bit of a different presentation, but it's the same thing. And then, guys, you can see actually shine x is actually what? It's the, now when you add two functions and divide by 2, so that's actually called taking the average, right? Or taking the mean value. So here what you do is you take the ex value and the negative e to the power negative x value, okay, and you divide it by 2. So guys, what they've done here is, can you see? So first we draw the ex graph. So that's what they've done over here, the red graph. Okay, so the red graph here is the e to the power x graph. Can you see? We already drew this. We already have this, right? So I've given it to you. And then, guys, the next thing they've done is they've taken the negative e to the power negative x graph. So, we drew that as well, right? So I have it over here. Can you see? This is negative e to the power negative x, this graph. So you can see that they've drawn that here as well in blue. Can you see, guys? And then, can you see the way they've drawn the shine x graph? So the way we draw the shine x graph here is simply by taking the average. So you take for the same x value, you take the two respective y values, you add them and you divide it by 2. And you can see the shine x graph goes exactly kind of like in the middle of these two functions. So at x equals 0, guys, you can see at x equals 0. Okay, so the value of the positive ex is +1. The value of negative x is -1. Add and divide by 2. That's going to be 0. So actually, all the entire graph goes in the midpoint. So this graph goes through the midpoint of all of these lines. Can you guys see what I'm talking about? So this point is the midpoint of these two y values. That's how it goes, right? So it's the average of the graphs of ex and negative e, negative x. All right, guys. All right, guys. So you can see, so shine x is the average of the two graphs. So you can see you kind of have a graph of this particular manner. Kind of looks like a cubic graph, right? So this is the shape and look of a cube of the shine x graph. So it's important that you identify its properties. Okay, so the properties, you can see it's kind of like a one-to-one function. So every x has a y value, right, guys? So those are important. You can see every x can give you a y value, every y can give you an x value. Okay, and then guys, a few more properties that I want to discuss about. Okay, so you need to know uh, what happens to each graph when your x becomes large and positive and when your x becomes large and negative, right? So you need to know this property for all the graphs. Okay, so what happens to y when the x value gets large and positive? Basically, what happens to the y value when your x value reaches infinity? Okay, positive infinity. And what happens to the y value when your x value reaches negative infinity? Okay, so guys, before I proceed on to that, I just want to go through these graphs and remind you something. So over here, guys, you can see in this particular graph, EX, I think you can see this graph, you can see it reaches 0. You can see this graph, the asymptote is x equals 0, right? It reaches 0 when x goes to negative infinity. Can you guys see? Because over here, when x goes to negative infinity, your graph, the y value reaches 0. Can you guys see what I'm talking about? As x reaches negative infinity, your y value reaches 0. Because you can see the y value gets closer. The graph gets closer and closer to the x-axis. So it reaches closer and closer to y equals 0. Okay, and here in e to the power minus x graph, you can see as x reaches to positive infinity, the y value gets closer to 0. Do you see what I'm talking about? You can see here as x reaches to the positive infinity side, the graph gets closer and closer and closer. The y values get closer and closer to 0. All right, guys. So in this graph, again, so how does it work? You can see as x reaches negative infinity, right? So you can see as x reaches negative infinity, your y value reaches to 0. And here as x reaches positive infinity, your y value reaches to 0. All right, guys. Okay, so you need to know about this. You need to know, especially, you need to remember, or you need to kind of know these results by heart, or it's best to remember the graph. Okay, so when you remember the graph, you know how each value, y value becomes zero when x goes to positive or negative infinity. So easiest way to remember that is by remembering the graph. All right, guys. Okay, guys. So keeping those results in mind, for the graph of y equals sine x, when x is large and positive. Okay, so let's talk about sine x. So y equals to sine x. So sine x is ex minus e to the power minus x divided by 2. Okay, so what we are interested in doing here is we want to check what happens to y when x is large and positive, and what happens to y when x is large and negative. All right, guys. So we're going to check for those limits. Okay, so what happens when x is large and positive? So basically, when x approaches positive infinity, what's happening here? So guys, when x approaches positive infinity, what happens to the positive ex graph? So you can see the positive ex graph when x approaches positive infinity, you can see this value is really large. Do you guys see what I'm talking about? So there is something significant if x approaches negative infinity. But if you take the positive ex graph, the ex graph as x approaches positive infinity, you can see it definitely has a large value, right? It has a large value. So that means there is a value there. So we'll keep it there as it is. Okay, so y equals the ex value will be there. I mean, you'll have a large value for it, right? So you can't ignore it. But what about the negative e to the power negative x graph? Negative e to the power negative x, guys, this one, the fourth graph. So you can see negative e to the power negative x graph as x approaches positive infinity, this value reaches zero. Can you see this value entirely reaches zero? So this value, the negative, so plus the negative e negative x part becomes a zero. Divide by 2. So that's why, guys, so you can see as the x reaches positive infinity, we reach half of ex. All right, guys, so that's what they're saying here. When x is large and positive, e minus x is small. So sine x is going to be approximately equal to half of e to the power x. All right, guys. So this is they're just trying to show you what happens to y as x gets large. So similarly, let's do the same thing when x is reaching negative infinity. So you get here y equals e to the power x minus e to the power minus x divided by 2. So when x reaches negative infinity, what happens to e to the power x? So you can see the e to the power x graph here. So when x reaches negative infinity, guys, you can see y reaches 0, right? So when x goes to negative infinity, y reaches 0. So this guy becomes a 0. All right, so this gets closer to 0. You have 0 here. And what about the other one? Negative e to the power negative x. So as x reaches negative infinity, guys, can you see as x reaches negative infinity, this graph, you get a large negative figure, right? So you can see as x gets closer to negative infinity, this value gets infinitely large, right? So then you have a value here, so that cannot be ignored. So you have a negative value, minus e to the power minus x. Whole thing divided by 2. So you get here an approximate answer minus half e to the power minus x. All right, guys. That's what they're talking about here. So when x is large and negative, ex is small. So sine x is equal to negative half of e to the power negative x. All right. Okay. And then one final thing here, observation. So for any value a, sine of negative a is equal to negative sine of a. I think you might remember this property was similarly there in the in the trigonometric sine function as well, right? So do you recall? So I'm talking about this property now. If you recall in trigonometric, if you had sine minus x, it's equal to minus sine, right? So similarly in hyperbolic also, you can see sine of negative x is equal to negative of sine x. Okay, so you can easily see this from the graph as well. Okay, so negative x, sine of the negative x is equal to the negative value of sine of x. Okay, so it's just, you can remember this as a property. Okay, so sin x is an odd function. Okay, so just have an idea of this. Okay, so mainly what you need to know here is to know the shape of the graph. Okay, and to know these y values when x reaches positive and negative infinity. Okay, and yeah, so you need to mainly know the shape. All right, guys. All right, guys, we'll move on to the next graph. So we're going to discuss about the graph of Cauchy. Okay, so next, so you can see, guys, Cauchy is ex plus e minus x divided by 2. Okay, so again, you can do the same thing that we did before. You can break the graph into two. So Cauchy is equal to ex plus e minus x divided by 2. So it's actually, in this case, cos x is the average of the ex and the e to the power negative x graph. So in this case, guys, it's the first two graphs. Can you see? So I had to get these two graphs, ex and e to the power minus x. So you draw both of these graphs in one, you plot both of them on the same axis. And then what you got to do is you need to draw a line that passes through the middle of the two graphs. I hope you guys are getting what I'm saying. So you can see what's happening over here, right guys? So the red graph here is the e to the power x graph. And the blue graph here is the e to the power negative x graph. And you can see the black line here shows the middle of the midpoint. So here the black graph goes exactly in the middle of these 2 points. Right guys, can you see? If I take these 2 points, if I join the 2 points, I mean the black graph goes exactly in the middle. Right guys, can you see? So these are the 2 main points. So the this point comes exactly in the middle of those 2. All right, so that's how you get the Cauchy graph. So you can see finally Cauchy graph. So it's a graph that looks like this, and one of the main and important features here, you guys can see it crosses the y-axis at 1, right guys? Because ex and negative e and e to the power negative x. So both of these graphs cut the y-axis at y equal 1, right? So because of that, the midpoint of 1 is, since both the graphs go at the point 1, they intersect. So because of that, you can see that this point 0, 1 is kind of like the lowest point of your graph. All right, guys. So that's an important point. And once again, we need to check what happens to the graph when x is large and positive, and what happens to the graph when x is large and negative. So when x approaches positive infinity, what happens to Cauchy x? So when x approaches positive infinity, guys, you know, e to the power positive x, when x approaches positive infinity, this is a large figure, right? Ex gets larger. So in that case, ex value, ex will have a large value. But e to the power negative x, guys, so you can see e to the power negative x, the second graph, as x becomes large and positive, e to the power negative x graph reaches to 0. So in this case, Cauchy x is going to be approximately equivalent to half of e to the power x. All right, guys. And then when x is large and negative, so what happens to e to the power x? So when x is large and negative, e to the power x. So guys, you can see when x is large and negative, see e to the power x, the graph, the y value reaches to 0. Okay, so that's going to be 0. And then plus e to the power minus x. E to the power minus x is this graph. So when e to the power minus x graph, when x reaches negative infinity, so over here, negative infinity means when the x values go to the negative side, you can see the graph gets large, the y values get large and larger. So you have a significantly large y value here. So that is directly the e to the power negative x value, right? When x is large and negative, you get an answer here, divide by 2. So you get here Cauchy x is approximately equivalent to half of e to the power minus x. All right, guys. Okay, so this is basically the idea here. Okay, so once again, it's really important that you remember the shape of the Cauchy x graph, right? So the shape and the minimum point here is 1. So you can see that, like for example, in the previous case, I think in the previous case, we were discussing this particular question, right? Where we were finding the answers where Cauchy x is equal to 2. Do you recall? So in this, in the previous video, in the previous exercise, we discussed this question where Cauchy x is equal to, and when we did it manually, you saw that we got 2 answers. Right, so guys, you can explain those two answers here from the graph. So this is Cauchy's. So guys, you can see here your Cauchy's graph is never gonna go reach a value below 1. Cauchy's graph is always going to be above 1. And here if Cauchy's is equal to 2, guys, can you see this is Cauchy's equal to, and you can see you meet the graph at 2 points. Can you see? So these 2 points gives you those two answers. Are you with me? So one answer was 1.32, the other one is minus 1.32. This is just going back to the previous exercise, showing you how things match, right? Because in the calculator, you only got one answer, but you can see in the graph, you get two answers. So the other thing I want you to understand here is if I ask you to solve cos x is equal to minus 1, what do you have to say here? So you need to immediately understand cos x graph is never going to reach minus 1. The cos x graph, the lowest it reaches is plus 1. Okay, so plus 1 and anything above that, it's fine as long as it's plus 1 and anything above that. So you can see in this case, the Cauchy's graph can never reach minus 1. In this case, there are no solutions. All right, guys, there will be no solution. Okay, so these are some important things you need to remember. So basically the range. Okay, so basically the range of the Cauchy's graph is going to be greater than or equal to plus 1. Okay, so that's really important. And remember, when you're solving equations, the moment if you see a Cauchy's value equivalent to a value lower than 1, okay, then immediately you know that you don't have to solve it anymore. Okay, but you can see Shine graph doesn't have that problem because you can get Shine answers for any y value because the graph is a 1-to-1 and it's continuing throughout the entire domain. Okay, so all the y values and all the x values are possible in the case of Shine X. But that's not the case for Cauchy's. The Cauchy's graph has a special property. So it's important that you remember these things. Okay. And then guys, again, you have this over here. So this is again something that's similar to the trigonometric function rule. So cos of negative a is equal to cos a. So guys, you should be familiar with this versus similar rule in trigonometry as well, right? So cos of negative x. So this is the trigonometry rule is equal to cos x. The negative mark does not come out. Okay, the negative sign doesn't come out. So in hyperbolic, it follows. Okay, cos of minus x is equal to cos x. Or else you can see it from the graph. The cos value of the negative x figure and the cos value of the positive x figure are both the same. Okay, so you can see it in the graph. So they say cos x is an even function because f of minus x is equal to fx. Okay, so this is again a rule that you need to remember. So it's quite easy to remember because it follows the trigonometric format. All right, guys. All right, guys. So we'll move to the next graph. So we're going to learn to sketch the graph of y equal tangent x. Okay, so guys, you know tangent x is actually sin x over cos x, right? So in the event of the tangent x graph, I think if you try to go for using the same method that we tried to using for sin and cos, it's not going to work because as you recall, tangent x is e to the power 2x minus 1 over e to the power 2x plus 1. So it's not going to work in those averages method. All right. So the way we approach this is a little bit different. Okay. So guys, so they have said here tangent x is sin x over cos x. We know that, right? So what they've done here is, okay, what they've done here is they've considered some critical points. They've considered some critical points and tried to construct the graph by using those critical points. So some of the main things they've done here is they've checked what happens to the graph when x is large and positive. Then again, they check what happens to the graph when x is large and negative. And the next critical point, they've checked what happens to the graph when x is 0. And based on those, they've tried to, construct the graph. So let me show you how it's done. So we know tangent is sin over cos, okay? And what they've done here when x is 0. So guys, when x is 0, what happens? What happens to tangent x? Right, so actually you can even get this from the calculator or you could, simply substitute values into the tangent x equation. Okay, so anything. Okay, any of the methods are fine. Tangent x equation. So what was the tangent x equation? All right, guys. So this is the tangent x equation. All you got to do here is when x is 0, you can replace the x value with 0. Tangent 0, e to the power 0 minus 1, e to the power 0 plus 1. So e to the power 0 is 1 minus 1. Here you have 1 plus 1. So 0 over 2 basically is a 0. All right, guys. So tangent 0 is 0. Okay, so that's one main point. Okay, and then we check what happens to the graph when x is large and positive. So what happens to tangent x when x approaches positive infinity? All right, guys. So what we do here is we are going to actually use the help of our previous result. So you know tangent x is sin x over cos x, right? Guys, we know the result, right? What do I mean we know the result? We know the result of sin x and cos x as x approaches positive infinity. We found them, right? We found them previously. So when x approaches positive infinity, guys, you can see here sin x. When x approaches positive infinity, sin x approaches to half e to the power x. Guys, can you see? So sin x approaches half e to the power x. So you can substitute that value here. So it's half e to the power x. Divide by, what about the cos x value? When x approaches to positive infinity, cos x. So we found here, right guys? Here cos x, when x approaches positive infinity, cos x approaches half e to the power x. All right, guys? So it's half e to the power x here. So divide by half e to the power x. So you can see they are equal to each other. So it cancels out and tangent x is approximately equal to 1. Right, guys? Can you see? So when the x value here approaches positive infinity, when in the tangent graph, as the x values get larger, positive and larger, the y value is reaching close to 1. Can you guys see? So here we have a proper asymptote in this case. We have a proper asymptote. So in this case, y equal 1 is an asymptote. All right, guys. So that's an important observation. Okay, so we can do a similar strategy when x goes to negative infinity. So what happens when x goes to negative infinity? So the same thing again. Tan x is sin over cos. So what happens when reaches negative infinity? So when x reaches negative infinity, sin x reaches minus half e to the power minus. So it's minus half e to the power minus x divided by cos x. Cos x, when x reaches negative infinity, cos x reaches half e to the power minus x. Right, guys? Can you see? It reaches half e to the power minus x. So you can see things cancel out here, but you're remaining with a minus sign, a minus, and when all the other terms cancel out with each other, you get minus 1 here. So as x reaches to negative infinity, or as your x values get negative and large, okay, negative and large, you can see that the graph is limiting itself to negative 1. All right, guys. So we have some major points here. So we're going to use those points to construct the graph. So can you guys, so what we do here is, okay, so this is the manual construction. This is the graph, okay, x and y. And you know there are two asymptotes, right? So what are the asymptotes? Y equals plus 1 and y equal minus 1. So these are our two asymptotes. All right, guys. So this is y equal 1. This is y equal minus 1. We know there are two asymptotes. And what else do we know? We also know the midpoint. We also know when x is 0, y is 0, right, guys? So we know that there is a point here. We know there's a point here. So now it's all about the behavior of the remaining part of the graph. So you could check the behavior of the remaining part of the graph by, inputting x values into the calculator. So you could input x values into the calculator to see actually how the graph behaves. So definitely we need to see asymptotes as as the x values get larger, the graph needs to get closer and closer to 1. And as the x values get smaller and negative and large, okay, as the x values get negative and large, the graph needs to reach closer and closer to this guy. All right, so using a few points here, you can see that this makes a logical shape. So this you can even check by putting values. I mean, you can input values in the calculator, so you can just do a few test values. Okay, but you can see definitely that it needs to reach these two asymptotes. So if you try to draw in any other way, I think it does not work, right? So if you try to make the curve the other way, it cuts the asymptote. Right, guys? Can you see? So the way to draw this logically to make sense. Okay. Is to draw it in this manner. All right, guys. So this is the graph of tangent. Okay.